What's up, what's up, what's up, what's up, guys? Welcome back. Dr. Jaws here, and tonight we are revisiting the sleeper sharks with Scymnodon ringens, the Knifetooth Dogfish. So, pretty cool deep water species, and we have a lot of good research lined up for tonight's shark. It is a denizen of the twilight zone and the midnight zone, so it spends pretty much most, if not all, of its time in deep water environments. For footage, there's not a lot on YouTube for this particular species, but we do have video of its larger cousins, the sleeper sharks. So, since they're in the same, or the other sleeper sharks, like the Greenland shark and the Pacific sleeper, so since they're in the same family, we'll go ahead and take a look at those cousins of the species, and then dive into this species itself. So, we'll wait for other people to join. Hold on. So, I think, and actually, I guess first before we get really started, we can kind of make some observations on the photo, or this photo right here, does depict a Knifetooth dogfish. So you can tell that it is a kind of. Hey Howard, what's up? Welcome back. Welcome back. Good to see you. I did get your email, but I didn't get an attachment for a drawing. So I think the attachment didn't go through. If you could resend it, I think I will be able to airdrop it on my computer. Because I know you made some art of the Knifetooth dogfish. So please go ahead and resend so that I can display it on the screen. And yeah, I'd love to see it. So, but I hope you had a good weekend. Like my weekend was pretty low key, not too much going on, so it's starting to get a little cooler, starting to feel a little bit like fall. Hey Minges, welcome back. Oh, no worries. I haven't been able to finish what I missed from last week, but I'm excited to learn about a new shark. Awesome, glad to have you both back. And then I don't know if you caught that, but Howard is going to be sending over a drawing. So if it works, I'll be able to airdrop it. And if it doesn't, no worries. Just send it to me later, and I'll be able to showcase it both on the channel and next week. So, but yeah, for this species, you can kind of make some observations just based on this photo. So you can see that it is. Oh, and also please let me know if the music is too loud or too soft. By the way, and I'll adjust accordingly. But you can see in this photo that this is a kind of dogfish, so a member of the order Squaliforms. It is missing an anal fin, so all Squaliforms do not have an anal fin. They have the pectoral fins, the pelvic fins, the two dorsal fins, and the caudal fin, but they don't have an anal fin, so that's something that's characteristic of dogfish sharks. What's also interesting is that I believe this species does not have spines, or it has very low spines. Let me double check that. I have my copy of Sharks of the World to kind of verify that. Let's see. Because sleeper sharks are interesting. Sleeper sharks are a kind so sleeper sharks are the family Scymnodon, and they're a kind of dogfish, technically, as far as like being in the order of dogfish. But they really are kind of their own thing as far as like they tend to be much larger species. And yes, it does have dorsal fin spines. You can't really see them well in this photo, but it does have dorsal fin spines, but you can obviously see that they're small. So other dogfish sharks, they sometimes have really prominent spines in front of the fins, but for sleeper sharks, or specifically this kind of sleeper shark, the fin spines are present, but they're very small. The body is pretty elongate and a little bit rotund. It's a little bit like a little bit of a stockier kind of build, and I feel like that's kind of characteristic of sleeper sharks as well. Huge, beautiful eyes with this reflective green coloration. So pretty cool sight. Oh, awesome! Thank you, Minges. It sounds like the music sounds good. Awesome. So yeah, really cool look to the species. So I think what we'll do is, before we dive in more into the Knifetooth dogfish species, we'll take a look at its cousins. And we've got some really cool deep water footage. So starting with this. We got a lot of cool deep water footage of different kinds of sleeper sharks. So this one is a Pacific sleeper shark. And the size is very different between full somniosis, like sleeper sharks like the Pacific sleeper or Greenland shark, these are really, really massive animals. The Knifetooth Dogfish, Scymnodon, is by comparison quite a bit smaller. But I think it's still helpful to kind of look at the family as far as like these are both sharks of the same family, and just to kind of get a general idea of how the Knifetooth Dogfish may behave or may move, since we don't have footage on YouTube of this species. So this is a really cool channel. I think it's called Alaskan Sharks. I'll X out of that, or I'll minimize that a little bit so we can get the full channel name. But there's a lot of cool clips of sleeper sharks from this channel. And what's kind of cool about these kinds of sleeper sharks, like the Pacific sleeper and the Greenland shark, oh, here we go, look at that. You can actually see some of the eye reflection in the bottom right corner. He swam off camera, but he might come back. But what's really cool about sleeper sharks in general is that they love cold water, and in areas where, oh my gosh, look at that. In areas where, like the Arctic or Antarctic, where shallow water is like freezing, like the sleeper sharks will be in shallow water. When you get into like warmer climates, like like the Mid-Atlantic, California, like those are like temperate zones, and then you get to the tropics, the Caribbean, or like you'll still find deep water, cold water in deeper water. So these sharks are still in those areas, but they occupy like the deep water environment. Because they don't really come to the shallows, and oh wow, look at this is so cool. Like the shark's just kind of coming out of the shadows, biting at this. I'm assuming there's bait in there, so this could be like a BRUVS, a baited remote underwater video surveillance or survey. This is so cool. But anyway, so and then I'm not really explaining that really well. So sleeper sharks like cold water, whether that cold water can appear in the shallows in the Arctic, or in the polar seas, or in the deep water of the tropics or the temperate zones. Like you can still find these sharks, at any latitude. It's just their depth is going to change. So when you start like in the tropics, these are going to be just in deeper water. But then when you get further and further north, where the shallow water gets colder and colder, you're more likely to see these kinds of sharks in shallow water. So I don't know if that makes sense. I kind of explained that a little poorly, but like let me know in the comments if that makes sense, as far as and I think it's kind of cool. It's kind of like if you did like a depth profile, it's kind of like this interesting like U-shaped distribution where like in the poles you can find these sharks kind of chilling in shallow water and actually have diving opportunities with these kinds of sharks. But then when you get to the temperate zone of the tropics, they're going to be really, really far down, and you can't dive with them or anything. Here in Alaska, shallow water is cold enough for this species, so you can actually have diving opportunities with this species, like this one. So this is clearly shallow water. This is sunlit zone, really shallow sunlit zone, and there is a scuba diver right there with this sleeper shark, which I would say is not probably advisable, because sleeper sharks are known to eat seals. And as you can see, this is a pretty big animal. Like this is a pretty robust kind of shark. So this one, again, since it's Alaska, this is probably a Pacific sleeper. So it's not the Greenland sleeper. But that does get to be a similar size. What's kind of wild is like this individual is just chilling. He's not really actively swimming. Or she's not actively swimming. I can't tell if there's claspers or not on this individual. And it looks like there is a tag on the top of the head. So what's kind of fascinating too, you could definitely see, the skin has these white spots. So that is either like, I don't know if those are denticles that have fallen off, or otherwise like skin kind of like peeling. These get to be some of the oldest sharks in the world. Some of them attributed to being centuries old, and it's kind of cool to see in this individual. Definitely, just by the look, I mean, definitely looks like an ancient animal, just in superficial appearance. So, shark is doing okay as far as it looks like it is still able to actively pump water. It is opening and closing its mouth. Now it's moving again. You can see a nice shot of the spiracles behind the head and bumping the cameraman. Wow, this is actually really cool. See, I just noticed that the diver in the top right corner, he was standing. So this is water that I'm assuming is shallow enough to stand in, unless the diver is just literally standing on the seabed, but he still has the water column above him. Wow, it's pretty amazing footage. On the one hand, I mean, it definitely is a sluggish kind of animal, so you know, don't touch animals, don't touch wild sharks. Please don't touch wild sharks. On the one hand, it's definitely kind of a sluggish kind of animal, so in that sense, it would. It seems like a slightly safe scenario, but on the other hand, again, it's such a large animal, and sleeper sharks are known to go after seals. They do eat seals. That it's just like, yeah, probably don't want to take your chances. So, okay, now this individual is actually moving at a pretty strong pace. That's a pretty solid swim. So no apparent signs of distress. No apparent signs of oops, sorry. No ads. No apparent signs of distress, no apparent signs of any kind of disorientation, maybe lethargy a little bit, but sorry, this channel is Alaska Sharks, so that was a really cool shot. There's a couple more sleeper shark shots from this channel, so highly recommend. Let me get out of here. Sorry, I didn't realize I had my email open. It is a lot of my bandwidth, but anyway, yeah. So Alaska Sharks is a really, really cool channel with sleeper shark footage. We'll have a couple other sleeper sharks to take a look at, but just catching up on the comments, like, oh my gosh, Minja, so wow, I was about to say, is it really that large, or is it the camera angle? That's insane. Yes, they get to be really, really big, like comparable, you could almost make it, like, probably comparable to tiger sharks or white sharks, so, maybe this one is, maybe this one's like used to humans in a way, like it doesn't seem subdued, it seems comfortable, but also seems weirdly used to what's going on, if that makes sense. Oh, Howard, thank you. I just saw your message on the attachment. Okay, perfect. So let me go ahead and I'll see if I can airdrop that. But, so that's a good point, Minjas. I think what's going on is that shark is probably not used to people. Because it's, I'm gonna make an assumption, but I feel like in Alaskan waters, it's probably not used to a lot of dive activity or human activity, and so the shark itself might be comfortable with humans in a sense that it's not really used to humans and maybe does not know how to react to them, and maybe is caught between assessing whether or not it's a prey item or it's just something large in the water, So that is my guess, but let's see. Let me pull up another clip while I open Howard's image. And thank you so much for saying that, Howard. This is a really cool shot. So this is, I think, if I'm not mistaken, so this is an oil rig or an oil platform, and here is a shark, a different kind of sleeper shark, investigating the platform, and it's pretty amazing seeing like this animal emerge out of the shadows. It's cool to think about the deep water environment where it's complete and total darkness, and yet these animals are just kind of drifting, lurking in the abyss. It's super cool. Let's see if I can do this. Okay. Sorry about that, almost there. There we go. Sorry, sometimes. Oh, that's a great shot of this shark. Oh my gosh, look at the profile on that. That is a well-fed individual. Oh my goodness. Oh my gosh, excellent footage of the species. So again, just for if anybody's joining late, this is not a knife-toothed dogfish. This is a kind of sleeper shark, either a Greenland sleeper shark or a Pacific sleeper shark. It depends. Oh, hold on. I think I just got Howard's thing. Hold on. Sorry about that. Let me just. Oh, there it is. Oh shit. There we go. Sorry, I always panic when I do this because I don't want like personal information out or anything. So, but I think we did this successfully. So here we go. So this is a knife-toothed dogfish. Howard, thank you so much for sending this over. And this is really, really cool because I love how you captured the dermal denticles and also are these photophores as far as like bioluminescence? Because I did see some studies that included the knife-toothed dogfish in bioluminescent studies. So these actually could be photophore pores. And if so, that's a really cool detail. But most exciting of all, I really appreciate, I know it's a little grainy, but I really do appreciate the focus on the mouth where, and actually that's a great jaw shape. That's a really good dogfish jaw shape. So that's actually really, really great capture. Just kind of like, you can see the part of the upper cartilage kind of not projecting out, but kind of like exposed. So you have like the lips around the mouth, but like the upper cartilage is exposed. You have the teeth being very prominent, especially in the lower jaw. That is actually a really cool rendition of that. So, and also again, I know this is pretty basic, but I really appreciate that you captured. This is a true dogfish, so no anal fin. You just have the pectoral fins, the pelvic fins, the caudal fin, and then you have the dorsal fins on the back of this individual, since we're seeing the underside of the belly. But this is really cool. So thank you so much for sending this over. This is a really, really cool piece on a species that is not well talked about. So or not really well known. So oh. Also, Minjas, I just saw your comment. That's a really cool idea. The shark stopped moving because of human. In that other video of the sleeper shark in shallow water, if the shark stopped moving, as far as thinking the humans were cleaner fish, that's a really cool hypothesis. I assume it's probably just the cold water still affecting the rate at which a shark moves. Because sleeper sharks, I forget what the right term is, but they have the same. Their body temperature is around the same as their environment. They don't have the same ability as mackerel sharks, where they can raise their body temperature. Sleeper sharks will be around the ambient temperature. So I think the sluggishness is probably maybe more related to that, but that's kind of my guess. Also, love the comments, Minjas and Howard, caught between seeing if the shark is chunky or terrifying. Really, really love that. So, oh, cool, Howard. I wasn't sure on the photophores, but I suspected their presence. Yes. So, this species is in bioluminescent studies. So, they may exist, and it is not unlikely that they do, because it is a dogfish. We know that. Not a dogfish, but it is a dogfish. It is a kind of squaliform, and we know that a lot of other squaliforms, like the cookie cutter shark, the lantern sharks, they all have bioluminescent capabilities. So that's actually a fair assumption. And as we go into the research tonight, we'll be able to verify whether or not this species does have photophores. I think it does, because it does appear in bioluminescent studies, but we'll go into that later tonight. So. And then, if you didn't see it, go back a bit to us turning away from the rig. The way it starts turning towards the camera was freaky. Oh, yes, please. So yeah, I do want to go back to this clip. But Howard, thank you so much for submitting this. This is tonight's species, the knife-toothed dogfish. There's unfortunately not footage of this species on YouTube, but we're starting out tonight taking a look at videos of its larger cousins, the sleeper sharks, like the Greenland shark and the Pacific sleeper, just to kind of get an idea of how this family works, as far as movement or behavior. Because it is, the Knifetooth dogfish is a kind of sleeper shark. It is in the same family as these two larger species. So let's rewind, and actually we'll go all the way back to the beginning because I do want to kind of fully appreciate this. But I'm glad how you were able to send that over. Thank you so much for sending. I definitely wanted to show it on the screen. Yeah. I love that there is a camera down here, and I'm not sure why the camera is down here. As far as, I don't know if this is part of, maybe it's part of just kind of like a visual assessment of the rig, and then the shark. This is just a clip of that where it's like the purpose was kind of examining the rig, and the shark just appeared on to camera. By the way, kind of fun trivia fact. Technical diving, like technical scuba diving, is arguably the most dangerous kind of scuba diving, and it would be, I forget the limits of technical diving in terms of how far you can go, but technical diving is diving in areas just like oil rigs, or to kind of like ascertain like the rigging, or diving in areas like dams, which have high water flow. It's super dangerous. I clearly will never do that personally. That's just my preference. But I asked my dive instructors like what the most dangerous kind of diving there is, and I assumed it was going to be like cave diving, but they said it's technical diving. That's probably the most advanced and riskiest. And they clarified it's the riskiest. Yeah, most dangerous is probably not the best term for that, but. Bravo to technical divers, because that is really impressive that they're able to do that. But pretty scary. Kind of scary also to think that you might be doing your job and this shark may be lurking in this environment. But look at the size of this, and actually, it looks like this is a female, because you can't see prominent claspers. So this is a female sleeper shark. And I love the comments, well fed or potentially pregnant. I just visually, I'm going to guess this is actually just a large, well fed individual. Really magnificent shots of this species. And again, I mean, like, I have the music I have on in the background is like Subnautica music, and it just fits so perfectly with. Imagine you're in the dark, and you're in the middle of a dark ocean, and this giant just comes out of the darkness, and you never know where it is. It's just kind of all around you, beneath you, above you, and you have no idea. Just kind of given the nature of that environment. So it's that I think is just riveting. I know people with thalassophobia would probably not agree. It's probably their worst nightmare, but I just think it's so cool to think that you could be in a deep ocean environment and you have no idea what's around you, and something like this could be around you, or like something like a sperm whale, or all these other like lantern sharks, or like hatchet fish or viper fish. It's just cool, really cool environment. The camera is definitely focusing on the shark now, so I'm not really sure. Kind of looking at the graph, I see oceaneering. I'm not really sure if this is a study of the rig or a study of maybe deep water habitat or deep water environment around the rig. I don't know. I apologize for these ads. I don't endorse any of them. But yeah, really cool shots of these sharks. So confirmed chunky. Yeah. Oh my gosh. Can't think of a reason to have a camera down there other than to either catch any malfunctions or just catch scary footage. Oh yeah, Howard, underwater welding and rebreather diving. Yeah, that's a good point. Ooh, that's scary. Unfortunately, that is how one of Oh gosh, was that Sharkwater? The filmmaker of Sharkwater. Um, and I won't go into too much detail because I am a little blurry on the details in terms of what happened. So this was filmmaker Rob Stewart was the filmmaker of Sharkwater. Part of he passed away sadly, and part of I believe they did. He was using a rebreather. He was like a master scuba diver. He really was very well experienced with scuba diving, but he sadly passed away, and part of it I believe was attributed to the rebreather he was using, because if I remember correctly, I believe he surfaced successfully, but what a rebreather is for scuba diving is it's kind of like a backpack that has a built-in scrubber, if I'm using that term correctly, that when you breathe out carbon dioxide, the backpack basically recycles it. It will separate the oxygen from that and I'm not exactly sure the details of it, and I'm also trying to be as generic as possible, but like it recycles the carbon dioxide that you're breathing. It takes the oxygen out of that, puts it back into your air supply, and then you breathe it again. The risk of that is you can develop oh gosh, I really there's something about that process where if there was something wrong with the equipment, like if the scrubber was not clean, or if some of how that recirculation, if something goes wrong, I think there's a couple different kinds of risks, including you're breathing like toxic air, or you're breathing like impure air, or unpurified air, and that starts to affect your cognitive ability. Also, there are like every kind of gas can basically poison you or affect you scuba diving, depending on what depth you're in, and how much time you are spending down at that depth. And because you can get like oxygen poisoning, you can get nitrogen poisoning or nitrogen narcosis, and then if you like swim to the surface too fast and gas expands, you can get the bends. There's a lot of problems that can go wrong, and rebreather, I think the risk is elevated as far as if there's something wrong with the equipment, if there's something wrong with like the scrubbing technology or the way that the carbon dioxide then oxygen is recirculating to your system, it can have an effect. And there was something like that going on in that particular incident. And I'm kind of being like vague and generic because it's a mix of like I don't want to get any details wrong, but I also don't want to. I mean, I don't want to get any details wrong in terms of how that technology works because I'm sure there would be angry dive comments if I got something wrong. But also this is a really cool shot. Actually, I might slow that back down just so we can kind of measure. Let's slow that down just so we can. I know that sped up, but I just want to measure the transition from the depth to the surface. But anyway, so rebreather is like it's like the technology that they use. It's the risk of developing like it's something about like how the gas absorbs in your body or the purity of the gas that you're breathing is higher with those if they go wrong. And there was something similar to that as far as what happened to that filmmaker, and it was really tragic. Oh, hey, Roy, well, what's up? Welcome back. Yes, may he rest in peace. I didn't realize he was a fellow Toronto Ontarian. Wow. Yeah. Also, speaking of rest in peace, this was really sad, but I do want to say this. I do want to make a comment. Just rest in peace today. James Earl Jones sadly passed away. And I mean, it goes without saying he was amazing. But for me personally, he's been an amazing part of some of my favorite movies. And like part of that is like, the Star Wars movies, but then a part of that is like Lion King like the 1994 is one of my favorite movies of all time. So just want to nod to James Earl Jones, an incredible actor, and he sadly passed away today. And sorry to kind of like you know, bring down the mood, but like, but he was just such an important person as far as like the art that I really love and the art that many people really love. So, yeah, rest in peace James Earl Jones, and rest in peace Rob Stewart. Just I think what was important is that Rob was a really important filmmaker for shark conservation. Sharkwater had a really big impact, and he really didn't do anything wrong as far as the diving that he did. It really, I believe the root cause of it was there was a failure on the equipment. There was something about the way there was something going on with the equipment that ultimately kind of snowballed into the events that happened. So sorry, that was a little bit of a tangent, but just Howard made a really excellent point that rebreather diving has really high risk. So has higher risk than normal scuba diving. So yes, voicing one of the most famous characters must have been a heck of a good time. Oh my gosh, one of my favorite voices. Really, really like James Earl Jones. Liam Neeson, also another Star Wars person, but James Earl Jones, Liam Neeson, some of my favorite acting voices. I feel like there's a big one that I'm really missing. But yeah, James Earl Jones, the iconic Darth Vader. Also a lot of good. I don't know if anyone's seen Hunt for Red October or some of the Jack Ryan movies like Patriot Games or what's the other one? Clear and Present Danger. He's really cool side character in those movies. So, but anyway, so for this shot, I did want to slow this down because I think it's a really cool transition from shallow water environment to deep water environment. So here we go. I know they sped it up, but let's just see how long it takes for the water clarity to start disappearing. So we have this baited remote underwater video survey with some kind of flounder. There's a bunch of kinds of flounder, by the way, like so many species. Even in the mid-Atlantic region, it's 20 species of flounder. So it's not one kind of fish, it's a bunch. So I can't tell if it's a flounder or a hake or a halibut or something else entirely, but here we go. So this speeds up, shallow water, nice and green, really pretty. You can start seeing it get a little bit deeper and darker. I dare say it actually looks a little bit maybe more turbid, so a little bit siltier. And look at that. Yeah, it does not take long to get into total darkness. So what's kind of fun, we might have talked about this before, but different colors fade at different depths. So different colors of light fade at different depths. So the first color to go is red. Red disappears at about 10 meters or 33... No. Sorry. Red disappears at about 4 meters, which is around 12 feet. Orange disappears at about... let me pull that up. It's red, orange, yellow, green, violet, blue, and then, you're in total darkness. So, and I'll speed this back up to normal speed. Normal speed. Here we go. I'm gonna figure out light absorption in water. Ooh. Oh, there's another flounder. There's quite a few flounder, actually. Okay, so red is about 5 meters, which is about, oh, there we go, 15 feet. Orange is about 10 meters, or 33 feet. Yellow is 20 meters, or 66 feet. And here is a shark. Green is 30 meters, about 99 feet. And then blue is 200 meters, so that's the end of the sunlit zone. Oh, man. So this is another Pacific sleeper. You can see a copepod on the eye of the species. Oh, this is... We'll kind of skip forward. Oh, here is another shot of shallow water Pacific sleeper. So can't tell if that's the same individual or a different individual. It looks like a different tag, so this may. Well, it's hard to tell because that looks like that's the same. That's the same shot of the diver holding on to the shark's fin. But some of these clips look a little different. So sleeper sharks are a pretty cool group of sharks to study. I remember in the 90s was the first footage. 1996 was the first footage of the species. This is actually really cool. This is a critter cam where we're following the shark's movements. That's actually pretty cool to see. Yep. There we go. This is a really cool clip that I think we saw when we did the Greenland sleeper shark. But this really shows you the size of these kinds of animals. Because this one, if I remember correctly, is gargantuan. There's a chimera bumping into the side of its body. And I know it's a little grainy. Oh, there's another shark on the left. I just saw the tail of a different shark on the left. I know it's really grainy, but there's a couple shots in this video that it will just kind of show you how massive this animal is. There we go. So if that is like a crab pot, like a standard size crab pot, this is I don't want to say monster because I never want to call a shark a monster, but like I would say it just as far as size. Like this is an enormous individual. Oh my gosh, it like can't fit into the frame at all. It's so big. Whew, there we go. There's a still of this sleeper shark. So if that is a normal sized crab pot, like this thing is incredibly huge. Oh my gosh, these sharks are so wild. Alright, yep. We've got a couple more short clips, and just again to kind of get an idea of sleeper sharks and their size. Let me catch up on comments. Oh, Quackers! Well, welcome welcome back. Japanese talk show covering the filming of commercial featured Super Shark. Yeah. Oh my gosh. Quackers! I'm sorry. What have I walked into? Oh yeah, Roy. I remember seeing this exact video, and some people said it was Megalodon in real life. So yeah, I can see. I mean, I can see why people say that. Unfortunately, and it doesn't help dispel the Megalodon rumors. So Quackers, to answer your question, so you're correct. This is not a Knifetooth Dogfish. This is a cousin. So these are sleeper sharks. This is either, depending on the location, if it's in the Atlantic, it's probably a Greenland sleeper shark. If it's in the Pacific, like we've been seeing a lot of Alaska clips, it's a Pacific sleeper shark, most likely. There's a couple other kinds of sleeper sharks. There's the frog shark, is another kind of sleeper shark. So these are all in the genus Somniosus. There's another genus, Scymnodon, which is Tonight species. We're going to be looking at the Knifetooth Dogfish, which is a small cousin of these giants, but they're in the same family. So there's no Knifetooth Dogfish footage, unfortunately. So we're instead going to take a look at the larger cousins, just to kind of get an idea of how they move and what they look like. And that would kind of help us. But it's both fun, and also it would kind of help us just kind of get an idea of just how the dogfish might move. So 2 more Super Shark clips. These are pretty short, but some of these are just really beautiful shots, so definitely wanted to take a look. And what's interesting is I don't think sleeper sharks have a dorsal fin spine, whereas the Knifetooth Dogfish does. So Scymnodon does have a dorsal fin spine. The Knifetooth Dogfish, Scymnodon ringens, lives in the Atlantic, so it is in the Atlantic or the Eastern Atlantic, so it will live in kind of outside of the Mediterranean, British Isles area. It's so cool seeing these like shallow water sleeper shark shots. I'm so used to sharks being in deep water, but all right, one more, and then we'll get to our dogfish. And I actually like these distant shots because they're kind of a nice approximation of how, again, the Knifetooth dogfish would move because they're in the same family. I love in this Pacific sleeper shark shot, you can see the caudal keel, so that's something that helps just with forward motion. These are strong swimmers, are sluggish, but they're still able to propel themselves through the water column. And they're no joke; they are predators in their own right. Sleeper sharks have had have been known to prey on marine mammals. They seem sluggish, but they're a pretty formidable species, or formidable group. So, okay, so that's enough footage. We'll dive into tonight's shark, a cousin of the sharks that we've just seen, Scymnodon ringens, the Knifetooth dogfish. Catching up on comments. Sleeper Shark says this product will make your hair fantastic. Oh my gosh. Probably too big to need spines. Yes, that's a good observation, Howard. You're probably right, because the spines probably serve like a defensive, well, almost definitely serve like a defensive purpose. We know that spiny dogfish or pike dogfish, they will, if they're handled by fishermen, they will arch their back so that they can stab fishermen or handlers with their spines. So that in itself indicates that the spines are definitely a defensive adaptation. Same with like horn sharks. Horn sharks have those spines, whereas if predators bite down on them, they can let go because the spines cause a lot of pain. So it's probably something similar with the Knifetooth dogfish as far as why it has dorsal spines. And then to your point, Howard, sleeper sharks being so large, they probably don't need those spines, and there's no need to evolve them due to their size. So here's the original description, original image from 1864, and it's actually not bad. It's actually pretty good, and it's kind of cool to see that you can tell that the shark is a little bit decayed, or a little bit, or not decayed, but like this has probably had some preservation. There's a couple hints to that. So one, the eyes look a little bit sunken in. Same with the nostril and the spiracle. The jaws are distended. So this is a species that, or this is an individual that probably has already started to undergo some preservation. The fins look, how do I say this? They don't look really flush or full. They kind of look a little bit thin. This one, the caudal fin, looks curved up and just dried out. Like there's something that like not so much with the pectoral fin, but in this particular drawing, the dorsal, caudal, and pelvic fins, they look a little bit emaciated, a little bit dried out, and then again the eye looks sunken in. So it's kind of cool that this is a simple line drawing, but there's hints that the artist was probably definitely looking at a preserved individual, like a shark that came, like they hauled up to the surface. And he probably didn't capture this image right at that moment. They probably preserved it in something like formaldehyde or alcohol, and then they took the shark out for the artist to draw. So, fun fact, when I used to work in the fisheries lab, I used to work with formaldehyde and alcohol for shark preservation, also just fish preservation in general. And boy, is that like unpleasant. It smells terrible. It smells like fruity, like fruity, like it's this weird putrid fruity smell that is like really unpleasant. And it was always scary, like when you put specimens back and like some of it splashes on you, because it's like, oh, those are carcinogens, like those are cancer causing particles, so that's not good. So anyway, here is a more modern illustration. Actually, this is a really good example. This looks more like a living individual or an individual that was freshly caught. This is actually really cool to compare with the other drawing, where see how the eyes look a lot larger, the jaw is not distended. The fins look more robust. The lower caudal fin in particular is a lot more flushed out looking. The dorsal fins look largely the same. The pelvic fin is actually quite a bit larger and quite a bit more fleshed out and robust looking than in the first drawing. So it's kind of cool to see that this one probably was taken from an individual that was freshly caught, whereas the other one, this definitely is a preserved individual. So let's see, common names: Knifetooth Dogfish, Araganhada, okay, Tiburon Bruja, ooh, I like this one, Messer Zanhai, fun. Let's see, short description: black in color, small dorsal fin spines, small lanceolate teeth without cusplets in upper jaw, and huge, high, knife-cusped cutting teeth in lower jaw. Mouth very wide and broadly arched, caudal fin with weak subterminal notch and no lower lobe. I don't trust this distribution. Let's take a look at IUCN Red List because I think it's a little bit different. Here we go. This is more accurate. So this shark lives in northwestern Africa, in western Iberia, and United Kingdom, on the shelf edge. Actually, look, this is a really interesting distribution where it's not really in shallow water. You can see, here we go. It's actually really cool to see. So here's the continental shelf, and then this, like in light blue is the continental shelf, and then this orange area is the actual shelf edge. So this is where the continental shelf, like the shallow water that is right next to the coast, it starts to drop off into the abyss. So it's kind of cool to see, like, this shark does not come close to the coast really. Maybe around these islands, as far as like these are, I don't know if it's appropriate to say volcanic islands, but like it looks like it's that kind of formation where you have the island and then, you know, this is not like a sandy single shelf area. It's like each island is plunging down into the depths. So it probably rings. It looks like it does ring the slope of the islands, because it looks like each island has a gap between the shark's distribution and its coastline, so the shark is still occupying shelf habitat. So it's actually really cool. Like, the shark is actually living on the shelves, but doesn't really go inshore at all. Pretty amazing distribution map, actually. It's almost perfectly like the shelf line of these areas. Interesting. Alright, so, but either way, it is an eastern Atlantic species. So, that other map had the western Atlantic, but it really does not live there. It lives in the eastern Atlantic. And I think we could probably get some good photos of the teeth on Fishbase. Fishbase is usually good about this. Let's see, fisheries, minor commercial, not marketed. It's good. Probably ovoviparous. Oh, sorry, yeah, ovoviparous. Bathypelagic. Depth range is 200 to 1600 meters, so that's the twilight to midnight zone. And here we go. This is what I really wanted to see, is the teeth. So here are the upper teeth. These are rather small, kind of peg-like looking. Very strange tooth type, actually, too. Like, these are... They almost look kind of squarish, which is kind of interesting. For the upper jaws. These are no joke. There's a couple teeth back here, like these recurves. These are really sharp looking. And then here we go. Look at that. This belt on the lower jaw. Now this is reminiscent of a cookie cutter shark or a kitefin shark. Kitefin shark have similar kinds of teeth where it's like this conveyor belt of teeth that are these beautiful triangles. Here, wow, look at this. A single cusp, no cusplets. Pretty uniform in size until you get further back into the mouth. But the front of the mouth is pretty uniform in size, and they're all interlocking. Look at that. So I wonder if this species, the Knifetooth Dogfish, does something similar to the other, to the kitefin shark, where kitefin sharks shed their teeth and swallow them as a single block. I would assume that's not what this shark does, but the only reason I'm bringing that up is because the teeth type is pretty similar looking to the kitefin shark, where it's just this long connection. It's pretty wild to see. So yeah. Oh my gosh, yeah. Quackers, I just saw your dissection. Probably preserve. And oh my gosh, sorry about that. I see a lot of preservation comments. Yeah, yeah. And just at least it'll preserve you well. Thank you. Yeah, Quackers. I definitely relate to that as far as just it's very unpleasant smelling. Like it's really unpleasant smelling, and it will. I hopefully will benefit. I hopefully will have a long life of sorts. So we shall see. Let's see. Howard, piscivorous dentition. Yes. So this is really good dentition for fish. Oh yeah. Quackers, I love cookie cutters. I find it really interesting. Casual looking at marine animals and notice random cookie cutter bites, especially on sunfish. Interesting. So yeah, actually, sunfish. Now that I think about it, sunfish would be a really good cookie cutter prey item because they're so slow moving. Like sunfish are. I mean, I will say sunfish are underestimated as far as they are very powerful swimmers and they can book it if they want to. But for the most part, their habits they do like drifting pretty lazily on the surface, and that would actually be a very good cookie cutter target. So. And like I love sunfish. They're super cool fish. A lot of people think they're like unpleasant looking, but I'm like no, they're cool. Very unique group of fish. But yeah. So wild tooth type for the species, man, these are great. Oh wow, look at these. You could definitely what a name. Like you could definitely see the namesake of the Knifetooth Dogfish with this photograph, like these teeth, like that's there it is right there. You know, I mean they look like literal daggers, like which is pretty. It's pretty cool to see. Like this is because like when you like I love kind of like learning this about sharks. It's like when you're a kid, when you start drawing sharks, you draw like these perfect triangles, and it's accurate for great whites kind of, but it's not accurate for other species. So as you get older and you start like kind of expanding your shark horizons, you start drawing more accurate, complex teeth type and teeth shapes. But it's kind of cool to see a species that brings it all the way back to just that simple design. The simple, just like it's just a triangular blade. Like just like it's kind of cool to see. Like no, there are sharks that actually have that kind of tooth type. Wow, here we go. What a jaw set. So you have the upper teeth, which are really spiky, the lower teeth, which are these enormous blades, and I'm almost like, I mean, I almost wonder, does this species function kind of like a cookie cutter shark a little bit, where it may not make like the cookie cutter bite, but maybe it grasps onto a prey item with its top teeth and then just shears into it with the bottom teeth? Potentially, because the teeth types are so different. Like the upper teeth are very narrow, very long and narrow, and the lower teeth are these like beautiful blades. I mean, they're just really like very robust, strong looking blades. So I wonder if other dogfish do bite onto prey items and will do kind of like the twisting motion to get big chunks of prey flesh off that item. The cookie cutter shark, of course, has its unique bite where it will bite onto something and then make a perfect cookie cutter bite. I wonder if this shark is somewhere in between. So we'll find out. Hopefully we can get some more information on the species. Trusty fish base. Let's go back to fish base's profile. Alright, Knifetooth Dogfish, Scymnodon ringens. So it's a sleeper shark. Scymnodon, Scymnus, an ancient name for some kind of shark derived from a Greek word meaning young animal, cub, or whelp. Odon means tooth, referring to a large triangular cutting teeth in the lower jaw. Ringens, Latin for gaping, referring to its large open mouth. Interesting. Getting a shot of these photos. Alright, so this is pretty interesting to see now. Can I get a closer view? I guess I'll have to zoom in. So this looks like a freshly caught individual. Kind of classic dogfish features. The snout is pretty short. Mouth is gaping. It is a really big mouth. It's kind of interesting to see that the mouth is really wide, but that the teeth are kind of more concentrated in the center of the mouth. So you have like the grasping teeth at the top right here. Sorry. Let me get out of here. Go back. And then the giant like knife-like teeth in the bottom here. But you see how like the jaw proper is, or sorry, like the teeth of the jaw are kind of concentrated in this like center area. But then you still have this huge maw, like this gaping mouth that extends beyond where the teeth concentration is. So I wonder why that is. I genuinely don't know why it does look like that, but it's kind of interesting to see that design, like that shape. The body looks, and part of it might be the photograph or the state of the individual, but it is interesting to see that this is not a dogfish like a squalidae, it's more closely related to sleeper sharks than it is to dogfish sharks, like to like the spiny dogfish. And what's kind of cool is like you can kind of see that as far as the body form, where it is a little bit chunkier looking. It's a little bit more robust looking. It's a little bit more squat looking. The dorsal fin spines are very low. Sleeper sharks don't have them at all, whereas this particular species has them, but they're very small. The pelvic fins are very far back in the body, and right above the second dorsal fin originates kind of not at the midpoint of the pelvic fins, but kind of close to the rear end, the rear edge, or the rear, like the midpoint to rear edge of the pelvic fins. So that's a pretty close looking arrangement. The lower caudal fin is squared off, and seems to be equal in surface area to the upper caudal fin. So this is probably a slow swimmer. Pectoral fins are very far up the body. The dorsal fins are both very weak. And the body itself is pretty robust again. So I could definitely see why this is more closely related to sleeper sharks than to other kinds of sharks. I wish that was larger. But kind of a view of the mouth is a little too grainy. And then this was the photo they had at the top of the stream, where you do have these like nice white grains. This actually reminds me of a gulper shark that we had in the lab, where it had these beautiful like, it had this like dark body, but it had these like beautiful like white points. I remember telling the biologist at the time, like it looked like a star field. It was really cool to see. And again, that gorgeous giant reflective green eye, which probably maximizes light absorption. It potentially works like other deep water sharks, where it potentially is trying to maximize light perception of bioluminescence. So potentially trying to find animals that are emitting bioluminescence in the ocean. So very cool, because other sharks with very large eyes have been known to do that. We covered one recently that was known to do that. So, oh, sorry, let me go back to fish base as far as notes on this species. Funky chunky fellas. Yeah. And thank you, Starfield is a beautiful way to put it. Thank you. Oh, Quackers, for a sec I thought you were talking about gulper eels, and I got very excited. Yeah, gulper eels are extremely cool. Very, very cool group of animals. But we also have gulper sharks. And actually, I'm not really sure why gulper sharks are called gulper sharks. Gulper sharks are also a really cool group. They don't have the distending capability like gulper eels do, but they're a really cool looking group of sharks where they're kind of like beautiful in their subtlety. Like they kind of have these like robust bodies. They have I believe they do have like dorsal fin spines. They look kind of more like a more robust looking dogfish. It's and not like this because sleeper sharks kind of like they also look robust, but they kind of look a little bit more with the smaller dorsal fins. Like they look more passive, you know. Whereas gulper sharks just look kind of like they kind of remind me of like a deep water version of the smooth hound a little bit. Like it's hard to explain. But gulper sharks are a really cool group of sharks. They're really rare group of sharks. So let's see. Biology for Knifetooth Dogfish, rare species inhabiting continental slopes. Usually applies to take in most often bottom. Its razor edge lower to use to attack and dismember large prey. Okay, interesting. So this guy is small, but he packs a punch. And that's all like dismembering prey. That's actually a little scary. So that makes you think like piranhas. Or if anybody is a Jurassic Park fan, because I know I bring it up a lot. Lost World Jurassic Park, the little compies. You know, just like they're small, but they can dismember something bigger than themselves. Oviparous. So this is the shark. Female shark lays. It technically lays eggs inside its body and then gives birth live, technically. So it's live birth without a placental connection. Utilize dried, salted for human consumption and for fish meal. Let's see. Not a lot of information on the species, but we do have a lot of research to cover. So, Knifetooth Dogfish is vulnerable, unfortunately. So it's been a while. Like we've been having a lot of hits as far as sharks that are doing well and that are at least concerned, but this one unfortunately is vulnerable. What's going on? The Knifetooth Dogfish is a small deepwater shark known from the northeast and central Atlantic, Scotland to Senegal, and the southwest Pacific, New Zealand oceans. Okay. Looks like New Zealand's not mapped on here. Yeah, I don't see a distribution map for New Zealand, but that could be a different species, like maybe under the same name. Or it could be the same species, but the distribution is a lot larger. So, it has been recorded from the continental slope at depths of 200 to 1,600 meters. The species is caught incidentally in trawl and longline fisheries operating across all of its known range, but the species may find some refuge at depth. There's high distribution overlap with intensive fishing pressure, reported declines in part of its range, but a stable population in others, and a lack of species-specific management across its entire range. The Knifetooth Dogfish is estimated to have undergone a population reduction of 30 to 49%, and is assessed as vulnerable. So, unfortunately, it lives near areas of high fishing pressure. And it's kind of interesting, we've talked about the Mediterranean before, and how there's so much fisheries activity in the Mediterranean. It's interesting that this shark lives at the entrance of the Mediterranean but does not enter the Mediterranean itself. So it's adjacent to probably one of the most, most alarming areas in the Atlantic as far as fishing and fishing impact on sharks. But it's interesting that this species does not live quite in that area, but it's still in an area of high fishing pressure as far as just kind of like the northern seas, Iberia, and then northwestern Africa. So, pretty interesting. I'm going to check. Usually IUCN Red List doesn't have a lot of biology notes, but nothing else is known of its biology. Age parameters are unknown, but can be inferred from a related species, the long-nosed velvet dogfish, Centroslacus crepidator, that has female age at maturity of 20 years and a maximum age of 54 years. Interesting. Alright. So I'm going to catch up on the comments. Oh, audio crunching, audio good. Sorry about that. Yeah. That's what we say about all sharks. Oh my gosh, yeah. Yeah, I probably, like, you know, just, I probably mentioned that, like, gulper sharks are beautiful, but, yeah, all sharks are beautiful, so, yeah, I mean, no denying. And it's kind of funny. Like when asked like what a favorite shark is, I really can't pick one. I think I could probably just do phases as far as like I currently am in the hammerhead phase right now, but I love all of them. So it's kind of like, and the only reason I'm in a hammerhead phase is because like that's it's a species I've seen in, or it's a group that I've seen in the wild, and like I just think they're really cool. So like seeing a shark in the wild and trying to connect it to like what you're studying is like a lot of fun. But I genuinely love all of them. Like there's no shark that I don't like. So okay, so research. We're gonna go back into the deep past. I think this is either from the late 1800s or early 1900s, and we'll see what we can learn about the Knifetooth Dogfish and also just like its deep water community in general. So I feel like it's been a while since we've had like just a pure research night. Either because we've lucked out on some really cool footage, or we had the puzzle special, or we've gone on to some really fun tangents. But I do have a lot of papers open up for this species, so we'll take a look, starting with this one. Excuse me. So genus Scymnodon. Generic characters. Upper teeth much longer midway along each side of the jaw. Lower teeth triangular, highest and symmetrical along median sector of jaw. First and second dorsal fin spines scarcely projecting beyond the skin. Dermal denticles on sides of the trunk scale-like. Okay. Okay, remarks. Gunther, which is a famous ichthyologist, thought that the passage from reclining to erect teeth in the lower jaw is too gradual to justify the separation of Scymnodon from Centroschymnus, or the separation of either of these from Centrophorus. Centrophorus is the genus of gulper sharks, for that matter. But the difference in dentition between the species referred here to Scymnodon and those referred to Centroschymnus is in fact so conspicuous that a glance at the mouth is enough to place a given specimen in the one category or in the other, provided it is properly referable to either. Properly referable to either, which makes the retention of Scymnodon as a separate genus a matter of convenience, even if nothing more. Interesting. The contrast is also interesting between the pointed or tridentate denticles. Let's see. I'm just going to kind of scan through this. Oh, cool. Is this shark? Can't tell if this is figure 13. I don't think this is it because the teeth look a little different. Let's make sure. The fins look the same. Oh, maybe it is. Maybe it is Scymnodon. Pretty cool illustration. This one is of a living individual, most likely. The eyes look full and fresh. Oh, here we go. 13C. This is it. Okay, so this tooth type is definitely a Knifetooth Dogfish. Because you can see... Let's see if we could zoom in for a better look. Okay. There we go. So this is definitely a Knifetooth Dogfish. And actually, it's kind of amazing to see the difference between figure C and figure H. Figure H has these like low kind of like teeth that are curving backwards. Figure C has these like really high teeth. They eventually curve back in the back corners of the mouth, but like the center teeth are really, really huge. Also, don't you love old illustrations like this? It's super cool, like older ancient manuscripts in science. I just think it's really fun. Okay. Named species referable to Scymnodon as defined here are Scymnodon ringens, Centrophorus scrombulosus, so it's a gulper shark, and Centroscymnus obscurus. The New Zealand shark, also that was described as Scymnodon sherwoodi, has been retained in that genus by several authors. So this is kind of really this is kind of showing a kind of like a history of what Scymnodon is, or like the Knifetooth Dogfish's taxonomic history. We won't spend too much time on this, but yeah, we won't spend a heck of a lot of time on this. So I'm just gonna skip ahead to see if there's a species profile on just the Knifetooth Dogfish. Also, I really appreciate that I can control find on an older article like this. That's actually really cool. Yeah, I think this is kind of more about genuses. I don't think it will be... I don't think it's going to go into the actual species, so we'll skip that. Here's a different older manuscript. Occurrence of Centrophorus ringens in British waters. So this is actually interesting. So this is the same species, Scymnodon ringens, but it was considered to be a gulper shark. Centrophorus is the group of gulper sharks. Oh, Quackers, I didn't think you were capable of not liking a shark to begin with. Thank you. Yeah, I appreciate that. I wonder if... I'm trying to think. Animals I don't like would be cockroaches. Can't stand them. They're awful. They're horrible, horrible things. Oh my gosh. It was kind of funny. Like, I used to live in Florida, and I had scorpions in my apartment, and those terrified me. But I also thought scorpions were really cool. So I was like, okay, this is awful that they're here, but you know, I'm also fascinated by them. Cockroaches, no, I hate them. I hate roaches. I cannot stand. Gosh, they freak me out. So that's an animal I don't like. Bees, I have a respect for them as far as like they're very important for the world, but wasps, I don't know if wasps are important though. I don't know. They probably are. But bees and wasps, not a big fan. Horseflies, I hate them. I really hate so really it's certain bugs. Certain bugs are probably the only kinds of animals I don't like are certain bugs. So yeah, let me know in the comments if there's an animal that you don't like. You know, either because you're scared of it or just it just kind of creeps you out or something. I'd be very curious, you guys, if you have any animals that you're not a big fan of. So yeah, but probably horseflies and cockroaches are probably the worst. I can't stand those. So, occurrence of Centrophorus ringens in British waters. A specimen of the shark, a female 4.5 feet long, was caught by line off Barrowhead, Outer Hebrides, in August last and was brought to Aberdeen Market. This species is common along the coast of Portugal. Was first described by Bocage and Capello as Scymnodon ringens. This fish is distinguished from the other 7 species of the same genus in the form of its teeth, by its scales, each of which have 3 high strong ribs on the surface, and by the possession of a strong, short, blunt spine in the front of each dorsal fin. Let's see. I have failed to find any previous record of the species for British waters, and shall be glad if any of your readers know of such. Interesting. And I think the rest are different articles. But that's actually a cool note. So that's brief but kind of cool. So cool fisheries note in terms of like the first record of Scymnodon. Oh man. Oh my gosh, Minjas, next time I'm back in my house, I'll make sure to take a picture of your book of my gorgeous, beautiful pet roaches. Oh my gosh. Yeah, are they the like are they that sounds terrifying, but are those the is it Mexican cockroaches? There's a group of cockroaches that are like the fat ones. The fat ones are I think people do keep those as pets, or they do something really cool. I know there's a group of cockroaches that are fat and cool, and I forget what they are. Like it's like if you touch them, they do this like this noise or something. I forget. So dubious is that what it's called? Oh my gosh, mine are sadly hissing cockroaches. That's what it is. Hissing cockroaches. Gotcha. Quackers, I love bees. There was a study done where bees had to travel across this path to do a task, and the path was unobstructed, but both sides of the path was there. It was just a bunch of balls. Every time they would stop to play the balls and to go on the task. Bees just love balls, and we don't know why. Love that. Oh my gosh. Like bees are cool. I like bees. We unfortunately do have, we have some kind of bee, like a yellow jacket, kind of nesting near our place right now, which we're taking care of that because like we don't want the bees near us. But like fluffy bees or honey bees, I like those because those are pollinators and they're really cool, like socializing animals. They're actually really, really cool. Wasps I don't like them. I really don't like them. Cicada killers. Have you ever heard of a cicada killer? That is something that we have in Virginia, which it looks like a giant nightmare wasp, but it's actually friendly. It's actually doesn't bother people because it, as its namesake goes, it hunts for cicadas. So we have like whenever we have both periodical cicadas and then also just normal cicadas, like the green ones. The green ones are normal. The black and orange ones are the periodical ones that come out every 7 years or so, and perform Armageddon on the world. So, but anyway, the cicada killers hunt both kinds, and they look terrible. Like they're huge, they're big, they're yellow, they're creepy. But like they don't bother people. Like those I'm okay with knowing that they just don't bother people. The other kinds of bees I'm not a big fan of. So, but yeah. Oh, quackers! I hate snakes though. Always have, probably always will. I've been terrified of them ever since like forever. So it's funny. Like I love snakes. I think they're super cool. One of my housemates cannot stand snakes. Does not like them at all. And I remember I showed him a video of, we had a black snake in our yard, and like I was just kind of like on the ground filming it, just kind of getting close to it, and the snake was going in S position, so it was going in strike position, so I kind of backed off. But like I was like filming it, and I was showing him. I was like, "Oh, isn't this so cool? Like this is a snake that we have." He's like, "What? What? Where is it?" I was like, "It's in our yard." And I was like, "Get rid of it." It's like, no, it's good. Black snakes are good actually. They help take care of mice, and they take care of copperheads. They will eat baby copperheads, which is really good. So, but I love them. A lot of people do not love them, and I think I think I'm in the minority opinion about snakes, but like I think they're super cool. But oh my gosh, yeah, like I have a snake stick. Because like I remember when I grew up a crocodile hunter, loved crocodile hunter, and I think I asked my parents for a snake stick, and I would wrangle some black snakes with it. I've never tried other species, never want to. I will say I have seen a cottonmouth in the wild, and even though I'm comfortable with snakes, that species was kind of freaky to see because of how venomous they are and how much damage they can do. So, So I respect those a lot. Or I mean, I respect all snakes, but like the vipers are like I have not seen many. I've seen copperheads and cottonmouths in the wild, but copperheads are pretty mild comparatively. But cottonmouths are like really venomous, and yeah, like they're. I think they're cool, but like they're also like really scary. Sorry, tangent. Scymnodon ringens. This is our last older report, and then the rest I think is going to be more modern. Let's see, more diagnostics of the species. I kind of like this. Dorsal spines feeble, projecting but slightly beyond skin. First dorsal fin much shorter than second. Let's see. Uniform brownish black. So not really new notes on this, so we'll kind of keep marching forward. This is more modern descriptions of the species, starting with 7. This is... I did read this one earlier. Graph 7, or sorry, photograph 7 is a Knifetooth dogfish. So it's kind of cool to compare this with other shark or other species because you can see. Hold on, let me really zoom this in. Okay, so you can see it actually really clear. You can see how far back the pectoral fin is, and how the second dorsal fin is actually kind of equal in size to the. Oh, I'm sorry, pelvic fin. I'm so sorry. Pectoral fin is the one up here. Pelvic fin. How far back the pelvic fin is, and how really close the second dorsal fin origin is to the pelvic fin. So it's almost kind of like you've got this like if the shark is swimming through the water column, you kind of got this like triangular fin pattern as far as like the 3 fins breaking that up, and then you have or breaking the flow of water up, and then you have like the caudal fin paddling side to side with pretty. And actually, in this individual, the lower caudal fin looks larger than the upper. So this shark would be a really cool one to do like physical swimming models of. Logistically, that would probably be extremely difficult to do because it is a deep water species. But if we ever have the technology, and I think we might already, but like it probably is really expensive to do like a pressurized tank and to kind of study the swimming movement of this species. I think it would be really cool because the physiology here, where you have these huge like, or not huge, but like proportionally large second dorsal fin and pelvic fins. I feel like the water, if you did like a water flow study or like a swimming study in terms of how this shark moves through the water, you would have some very interesting findings. So that would be a cool project to do with this kind of species. So you can see the teeth kind of prominently here. The eyes are proportionally, I mean, they're large for the shark's body, but it's kind of cool to compare with other similarly related species where you can see some differences. This one I think is Dania. This looks like a Portuguese dogfish, although I could be wrong. I can't tell what a lot of these other ones are. But these are all kinds of squaliforms, so fairly closely related. And here's Scymnodon ringens. Not really new notes. Just kind of more. This is more like a visual of the species. So again, it's number 7. It's this one right here. Here is an FAO catalog. FAO catalog on this species. So here we go. Scymnodon ringens. No synonyms. Knifetooth dogfish, also known as bruja in Spanish, or Squale-grogner commun in French. Probably butchered that. Here's a nice graph of the species. This is, I think, the same drawing we saw earlier, so taken in life. Pretty interesting figure of the other underside of the head with the prominent teeth. Here we go. Here's the map. So again, the continental slope. Lower teeth relatively large, triangular, blade-like. Caudal peduncle asymmetrical, not paddle-shaped, with weak subterminal notch. Coloration is black with no conspicuous markings. So we're seeing it may not have photophores. I thought this did, and we'll keep looking at the research. I thought this shark did have photophores, but I could be wrong because we keep seeing notes that the coloration is black. Da, 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 da. Habitat: a relatively common, little-known deep-water, temperate to subtropical shark of the eastern Atlantic, continental slope on or near the bottom at depths of 200 to 1600 meters. This is a weird note. Viviparous with a yolk sac. That's really different from what ovoviparity is, and most dogfish sharks or sharks related to dogfish are ovoviparous. So this might be a mistake. So we'll kind of keep an eye on that. This actually might be a typo. The immense triangular razor-edged lower teeth of the shark suggests that it is a formidable predator capable of attacking and dismembering large prey. Maximum length is 110 centimeters, so it's about 3 feet. Although we did see a paper saying that was 4.5 feet. Let's see, centimeters to feet. Uh, 3.5 feet. This species is of limited fisheries interest. It is caught as bycatch in bomb trawls and nets, and by longline gear, but rarely reported separately, and is generally included with other deepwater sharks in mixed landings. Since 2006, an average of 205 tons in landings was reported at FAO, with most of the landings coming from Portugal and Spain. Nothing is known about its life history or population structure. It is utilized dried salted for human consumption and for fish meal. The conservation status. So this has been updated since this publication because it says it's data deficient due to insufficient information, but we know as of today in 2024 it's vulnerable. So local names: Aragandhada in Portugal, Messerzanhai in Germany, and Quaneraj in Sweden. Okay, I'm probably butchering all that, but. Okay. But I do like the profiles that the FAO guides create, so getting a little bit more information on Knifetooth Dogfish. Again, the second time we've seen that this is probably a shark that dismembers larger prey. It's kind of cool. Oh, here we go, a bioluminescent study. So we'll take a look at that. Alright, because I do want to check this. So molecular phylogeny of squaliforms and the first occurrence of bioluminescence in sharks. So this is by Nicholas Straub, Changhong Lee, Julian M. Kleis, Shannon Corrigan, and Gavin J.P. Naylor. Here we go. So abstract. Squaliform sharks represent approximately 27% of extant shark diversity, comprising more than 130 species with a predominantly deep-dwelling lifestyle. Many squaliform species are highly specialized, including some that are bioluminescent, a character that is reported exclusively from squaliform sharks within chondrichthyes. So that's actually really cool. We might have seen this paper before, but I think it is good to revisit, because it is really cool to think about that no other order of sharks emit light, that it's only squaliform sharks that are capable of producing bioluminescent light. The interfamiliar relationships within the order are still not satisfactorily resolved. Herein, we estimate the phylogenetic interrelationships of a generic level sampling of squaloid sharks and closely related taxa using aligned sequences derived from a targeted gene capture approach. The resulting phylogenetic estimate is further used to evaluate the age of first occurrence of bioluminescence in squaliforms. So, really cool. They're using genetics to determine when did bioluminescence evolve. So that's actually really cool. Results. Our dataset comprised 172 putative ortholog exon sequences. Phylogenetic estimates result in a fully resolved tree supporting a monophyletic lineage of squaliforms excluding Echinirhinus. Okay, so that's really cool. So this is, what that's saying is, we've talked about this before, but the bramble sharks, Echinirhinus, they used to be considered squaliforms. But I think it's like studies like this kind of suggested that it's actually, those sharks are so distant that they're kind of their own thing. So it's really cool to see that all the squaliforms have a same common ancestor, hence being monophyletic, but that the Echinirhinus are not part of that grouping, and so they actually should more appropriately be their own thing. And that's what we have today. So today we have echinorhinoforms, which is an entirely new order of sharks. Because as we got into better grasp of genetics, we realize that Echinorinus and Echinorynidae are just different. They're just too different from squaliforms. So, and it's really cool to see that in this particular study. This one is from 2015, if I have that right. Yeah, copyright 2015. So, yeah. Non-luminous Squalidae are inferred to be the sister to a clade comprising all remaining squaliform families. Our results suggest that the origin of photophores is coincident with an elevated diversification rate in the splitting of families Delacidae, the kitefin sharks, Hemipteridae, the lantern sharks, Oxynotidae, the rough sharks, and Somniosidae, the sleeper sharks. Like our Knifetooth Dogfish is a sleeper shark. It is a somniocid. At the transition of the lower to the upper Cretaceous. The presence of luminous organs was confirmed for the sleeper shark genus Zamius. Okay, so that sounds like our shark probably doesn't have photophores, but a close cousin does. These results indicate that bioluminescence in sharks is not restricted solely to the families Hemipteridae and Delacidae as previously believed. So the lantern sharks and the kitefin sharks, including cookie cutter sharks, they have bioluminescence, and I guess apparently they were originally thought to be the only sharks with bioluminescence, but Zamius, which is a kind of sleeper shark, apparently has that too. And our shark, the Knifetooth Dogfish, it sounds like it still doesn't have it, but it's kind of cool to see that its cousin does. So, conclusion. The sister clade to the non-luminous Squalidae comprises 5 families. The presence of photophores is reported for extant members of 3 out of these 5 families based on the results of the study. For example, the lantern sharks, the lantern sharks, kitefin sharks, and sleeper sharks. Our results suggest that the origin of luminous organs arose during the rapid diversification event that gave rise to the extant squaliform families. These inferences are consistent with the idea of the diversification of squaliform sharks being associated with the emergence of new deep-sea habitats in the lower Cretaceous, which may have been facilitated by the evolution of bioluminescence. So that is extremely cool. This is a really, really, really cool paper. So I think we'll just kind of scan through this and then just fast forward to some of the visuals. Okay, here we go. Oh, this is really cool. Okay, so here is the maximum likelihood phylogenetic estimate of squalomorph sharks. So this is actually really cool. So you can see squaliforms right here, which are all the colorized areas, but then you can see the root, the tree, all these offshoots. So this one, Hexantius griseus, that's a 6-gill shark. So 6-gill sharks, like the cow sharks, like Hexantiforms, that is so distant and so removed. That's a whole other branch. Within this, you have these 2 branches. You have Echinorinus, so that's the bramble shark. Echinorinus brucus, that's a whole other thing. Squatina, that's a kind of angel shark. So Squatiniforms, Echinorineiforms. And then Pristophorus, that's a saw shark. Pliotrema is also a saw shark as well. So the saw sharks, angel sharks, bramble sharks, and cow sharks, these are all broken off into different groups. And then again, all the colorized area are the squaliforms, which are the dogfish. So green is Squalidae, classic dogfish. We go in, gray is Centrophoridae, so these are the gulper sharks. Yellow is Delacidae, these are the kitefin sharks, including the cookie cutter shark. This is interesting. We'll talk about blue in a second. Pink is Hemipteridae. These are the lantern sharks. Okay. And then blue is Somniosidae, which are the sleeper sharks, like our shark. Now, this is really cool to see, where when you look at this tree, so you have the beginning of Somniosidae, the sleeper sharks here. You have this one off group, which is Somniosus microcephalus. This is the Greenland sharks. These are the big, big sleeper sharks that we were seeing earlier in the stream. And then this group right here, you have Zamius, which is the only one that we know has bioluminescence. Centrosolacus, Scymnodon, and Centroscymnus coelolepis. I think Centroscymnus is a Portuguese dogfish, if I remember correctly. But anyway, Scymnodon ringens, this is our knife-toothed dogfish here. But take a look at this. You have nested within this family Oxynodus, which is a rough shark. And that has evolved into its own family, Oxynodidae. So Oxynodidae, the rough sharks, might be something that evolved from the sleeper sharks. And what's really cool about that is, you remember we were talking about how the knife-toothed dogfish has those weird, like, the dorsal fin and the pelvic fins are really close together, and you got this kind of pyramidal shape, or not pyramidal shape, but kind of like the three fins acting really closely together. That's something that you do have in the rough sharks as well. So, and that's really cool to see that feature physically, because it's like, oh wow, so that they genuinely might be really closely related. Like that may be kind of like a derived trait, where you have the second dorsal fin and then the pelvic fins really close together in this weird like triangular kind of shape pattern. So that's really cool to see that Oxynodidae might be nested within Somniosidae, that the rough sharks might be an evolved form of the sleeper sharks. So I think that's really, really exciting, actually. So if this is the same paper that I'm thinking about, let's see if there's... oh, here we go. It's kind of the same thing. So, except this is plotted on the timeline. So it's kind of cool to see, just for comparison, you've got the Upper Cretaceous period, so this is the time of like T-Rex. And around that time you can see some of the gulper sharks splitting off from Diania, which are like the arrowhead dogfish. You can see the sleeper sharks, around the time of T-Rex, the sleeper sharks split off from the Greenland sleeper shark split off from the rest of the sleeper sharks. So the Greenland sleeper shark line split off from the rest of them. And then around the time of T-Rex, you have all the lantern sharks coming to light. Oh, and I think... Okay, this is actually a really cool tree. So, these light blue areas, these light blue bubbles are indicating bioluminescence, and red indicates none. So it looks like bioluminescence may have appeared around the Lower Cretaceous period, just like the paper was saying. The squaliforms don't, the Squale-grogner, the dogfish don't have it. When you get through the Lower Cretaceous period, there's a likelihood that it still was evolving. The gulper sharks don't have it. I mean, there's a tiny likelihood maybe some ancestors did, but really most likely not. Definitely by the Middle Cretaceous, you definitely have bioluminescence. The kitefin sharks definitely have it, so this is all like bioluminescent. The lantern sharks definitely have it, so that's all bioluminescent. And then the sleeper sharks, which assumedly came from the same ancestor, lost it. So Zamius still potentially has it, but the rest lost it. So it's actually kind of cool to see that. So if I'm reading this tree correctly, it's suggesting that bioluminescence evolved around the Lower Cretaceous period. So the common ancestor of the kitefin sharks and the lantern sharks and the sleeper sharks had bioluminescence, but the sleeper sharks then evolved away from it and didn't have it anymore, which is really cool. That's actually really cool to see that form of evolution kind of working. So, all right, I'm gonna just jump to Scymnodon, but I guess the last kind of fun note is that Scymnodon kind of became its own thing in the Oligocene. So, is that 29 million years ago? No. Yes, yeah, 29 million years ago. So, very cool. Thanks, Minjas. I'm too sleepy to properly put my amazing into words, but whoa, thank you. So yeah, actually, I didn't realize how late it was, so it's almost 10:40. If you guys have a shark suggestion for next week, please let me know in the comments. I have one as well, but I'm gonna hold back just in case anybody like has a shark that they would like to do next week. Please let me know. And if not, probably around 1050, I'll type in my suggestion. But let me know if there's a particular shark you want to do next week, and then we'll cover it. This is an evolutionary tree. We have seen this before. I think we'll kind of move on because we basically kind of got the same information from this really cool bioluminescent study, so I think we'll move on. This is another field guide for Scymnodon ringens. So a similar kind of drawing with the big teeth. A drawing that probably was taken from life. You get to see the big mouth, the bulging eyes. Yeah, I think this is kind of more like a ID guide, so we'll keep moving. Oh, here we go. This is something that's, and fingers crossed, this might be a lot of information, because that is a beautiful looking illustration. Okay, that's cool. Scymnodon ringens. Okay, the Knifetooth Dogfish. Okay, beautiful illustration. You can clearly see the tiny spines. You can see how far back the dorsal fin is. This is an amazing illustration. You can actually see a midline, like the lateral line, actually, or kind of like a pretty prominent ridge on the midline. That's actually really cool to see on the body. Large eyes, reflective eyes here. Here we go. Diagnostic characters. Germinal tentacles of back with cusp and longitudinal ridges, but no transverse edges in young adults. Snout broadly rounded, shorter than mouth width. Mouth very large and strongly arched. Upper teeth much smaller than lower teeth, not blade-like, with extremely long, slender, erect cusp and no cusplets. Lower is very large, unserrated, compressed, blade-like, with a single very large, erect or semi-erect cusp, no cusplets. Pectoral fins with their inner corners rounded, pelvic fins very large, caudal fin with subterminal notch hardly indicated, color uniformly brownish black. Anything else? Very small spine. Okay. A deep water shark of the continental slopes and outer shelves, ranging from 200 to 1600 meters depth. Offshore in the northern part of the area, the large jaws and teeth of this shark suggest it is a formidable predator on fishes, other sharks, and benthic invertebrates. Properly ovoviviparous, separate statistics are not reported for this species. Caught in bottom trawls, also fixed bottom nets with line gear. Utilized dried, salted, and for fish meal. Okay. Man, and that's it. Not a lot of information on this species. Really cool illustration though. That's actually really cool. Okay, what is this? Okay. Just going to scan through this. Several shark species occurred in less than half the time series considering this amount. Alright, so it's basically saying it's kind of a rare species still, so we'll kind of keep going. This, I think, is like a checklist. So we'll keep going. I don't know if this has the Knifetooth Dogfish, so we'll keep going. Oh, this one does. Here we go. Okay. Oh, Quacker's saying the brains and bringing on too much, but this is epic. Oh, thank you. Oh, this is cool. No sharks in mind, no worries. I have a pretty important one that I didn't realize we never covered before. If it sounds good to you guys, the dusky shark, Carcharodontis obscurus. Yeah, sorry, I spelled that right. Carcharodontis obscurus. This one is really... I'm actually surprised we didn't cover it before. This one is a really important species on the east coast of the United States. This is arguably the... This species helped launch, I would say... How do I say this? Like modern American shark research. Quackers, I thought we already did that one. Let's see. I don't think we did. We did the dusky smoothhound, but I don't think we did the dusky shark. Let's make sure. Hold on. I'm gonna check my playlist really quick because I have all the playlists in by taxonomic order. So we did the bull shark, got sandbar shark, spear-tooth shark. We did a lot. Lemon sharks, black-tip reef shark, blue shark. Man, we did a lot. Pig-eye shark. We did the pig-eye shark. Oh my goodness. Spinner shark, graceful shark, bronze whaler, which does get confused with it sometimes. Hard-nosed shark. Yeah, we didn't do it. Yeah, we did not do dusky. All right. Yes. Oh, okay. I see. Yeah, the dusky smoothhound. Yeah, so we did do the dusky smoothhound, but we didn't do the dusky shark. Dusky shark is a really cool species. So this species is, for shark research, one of the most important. Definitely in the United States. This has been the pillar of modern American shark fisheries research. Jack Music, who was one of basically like the most important American shark scientists in the world, and one of the big figures, pretty much the founder of the shark research program at VIMS. Dusky sharks and sandbar sharks were kind of his two big, and actually I have a dusky shark up here. The top left corner of my poster is a dusky shark. The bottom is a sandbar shark. But yeah, like the dusky shark is really, really important for shark research. Dusky sharks and sandbar sharks are probably the pillars of American fisheries shark research, at least in Virginia, or at least in the Mid-Atlantic. Very important species for that reason. The other cool thing about dusky sharks, they're the biggest shark in its genus, Carcharinus. So it's the same genus as bull sharks, the same genus as sandbar sharks, but it's bigger. It's bigger than a bull. It's bigger than the sandbar shark. These are coastal pelagic predators that I remember hearing that they go after whales in packs. So these are really cool sharks. I'm very excited to go for them next week. So yeah, let's do dusky shark. Quackers just saw your comment. Yee, shadowy shark it is. So yeah, I'm really excited. It's a really important species. It was like the first book I ever wrote, like the little books, is on a dusky shark, and it's a personally important species for a lot of reasons, but also an endangered species. I'm excited to cover it next week. That one's a big deal. So yeah, it's gonna be a cool stream. It's gonna be really cool.
This is a pretty interesting paper. Glimpsing ecology of deep water sharks and important crustacean fishing ground.
Sophia, I don't know that letter. It's not C. I don't know how to pronounce it. I apologize. Sophia Aranha, and I apologize for messing that up. Alexandra Teodosio, Vania Batista, Karim Irzini, Esther Diaz. Abstract. Deepwater sharks are one of the most vulnerable deepwater taxa because of their extremely conservative life history strategies, for example, or that is late maturation, slow growth, and reproductive rates. Yet little is known about their biology and ecology. Thus, this study aimed at investigating the trophic ecology of 5 deepwater shark species: the birdbeak dogfish, Diania calcea, the arrowhead dogfish, Diania profundorum, the smooth lantern shark, Edmonopterus pusillus, the blackmouth cat shark, Galeus melostomus. Oh, we might have looked at this recently. And the knife-toothed dogfish, Scymnodon ringens, sampled on board a crustacean bottom trawler at the southwest coast of Portugal. The combined carbon and nitrogen stable isotopes of RNA and DNA ratios to investigate the main groups of prey assimilated by the species and their nutritional condition, respectively. We did see this because we were doing this with the blackmouth cat shark. Stable isotopes revealed overall small interspecific variability in the contribution of different taxonomic groups to sharks' tissues, as well as the origin of their prey. The knife-toothed dogfish presented higher nitrogen and carbon values than the other species, suggesting reliance on bathyal cephalopods, crustaceans, and teleost. So it looks like our dogfish is going after prey items that are close to the bottom. The remaining species likely simulated bathy mesopelagic prey. The RD ratios indicated that most of the individuals had an overall adequate nutritional condition and had recently eaten. This information, combined with the fact that stable isotopes indicate the sharks assimilate prey from the local or nearby food webs, including commercially important shrimps, suggests a potential overlap between this fishing area and their foraging grounds, which requires further attention. Alright. This is really cool. So, I want to just see if I can hone in on... it looks like it's not a lot of notes on the Knifetooth Dogfish specifically, so just want to kind of scan through that. Blah, 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 blah. Really beautiful graph of... yeah, and actually this is Portugal, and you can see this study area is actually entering into the shelf, so the Knifetooth Dogfish's habitat. Let's see. A lot of contribution of each prey group. So Scymnodon ringens is down here. So a mix of octopus, shrimp, and teleos, which is a group of, or the most group of bony fish. So it's kind of interesting. Like when you see this, this kind of starts to undercut the idea that this shark maybe goes after large prey and dismembers large prey, because it clearly is. I mean, you know, the shrimp are small. The octopi probably kind of small. I'm not really familiar with the few Atlantic octopuses that I'm familiar with. And also, you can use both, by the way. I believe octopuses or octopi, they're both fine as far as the plural for octopus. But I don't think we have an Atlantic species that is huge. Like, in the Pacific, you have the giant Pacific octopus. But in the Atlantic, I don't think there's an octopus species that is really big. So this shark might be going after prey items that are not as big as we originally thought, potentially. Because it looks like, based on this study, they're going after smaller prey items, is kind of my inference from that. So, let's see. Despite the small sample size of these especially inaccessible organisms to trophic studies, we were able to show that the sharks studied here are tertiary consumers, assimilating cephalopods, crustacean, and teleos with bathyal and mesopelagic origins from the local food webs or from nearby areas. They're generalist predators, which is kind of funny because I think you can call most sharks generalist predators. If it's not a hyper specialized feeder like a basking shark or like a bullhead shark, like the horn shark or Port Jackson shark, it's probably gonna try to eat anything smaller than it for the most part. But still, really interesting study. Okay. We have a couple minutes left, so I'm just gonna crash course Scymnodon. Let's see if we can find any more notes on our species, the Knifetooth Dogfish. Don't think so. Oh, there's a lot here. Wow. Alright, we're just gonna leapfrog. Scymnodon ringens, sorry. Scymnodon ringens. This is about the dermodenticles, so the scales. Our shark, this is kind of interesting. Our shark has, this is a micrometers. Do I have that right? Micrometers. A microscope view of the dermodenticles. So you can see our shark is figure C. The Knifetooth Dogfish has these kind of denticles that are pretty raised. And you can see how they overlap with each other. Interesting. Kind of keep looking. BEH. So B, E, and H are the overlapping scales of the Knifetooth Dogfish. A, D, and G, C, F, and I are different species. Yeah, this is a pretty detailed study. It's cool. I don't think it's going to show anything new on behavior, so we'll check one more thing. But I don't think that's going to show anything. Yeah, this is kind of more of a general study on shark genetics, and we already kind of did a cool study on that as far as the bioluminescence go. So we'll go back up to that tree because I thought that was a really, really cool chart on, there we go, on evolution of bioluminescence and where our shark fits in that. So, all right. Oh, oh, I think I just missed. Hold on. Audio get crunchier than my cookies when I burn them. Love it, Quackers. Oh my gosh. Truly, my only failing as a human is my inability to bake. I can cook real well, but just you know what's really funny? Oh, Howard. Oh, that's awesome. I appreciate that. If that's your only failing, you're doing very well. I appreciate that. That's really cool. You know what's really funny though? Like I feel like that's such a thing where it's like it's you either cook, you either are a very good cook but not much of a baker, or you're a very good baker but not much of a cook. And it's kind of funny, like for like my girlfriend is a really good cook, and she doesn't really bake as much. I really like baking a lot, but I don't cook as much, and I'm starting to kind of get better at it. And likewise, my girlfriend's starting to get better at baking, and like we're kind of complement each other in that way currently. But like it's funny, like it's never. It's so funny how it's never both. Like it's like either or. I really feel like it's like you're good at one and not so good at the other. It's always the case. And it kind of reminds me of like I remember that in college where it's like you're good at biology but not so good at chemistry, and then vice versa. You're good at chemistry but you're not so good at biology. Like I feel like it's you know, a yin yang kind of thing. I don't know what's going on there, but I think it's such a funny dynamic because I think it's so common. But yeah, man, and Quackers, that's got me hungry too. Because what's kind of fun is it still feels a little bit like summer, but I can tell just with the days getting shorter, we're pretty much in fall. We're starting to really get into fall. So it's that time of year to get the good food going, and I'm actually really excited about that. I love doing ocean things and like summer things in the summer, but then I do enjoy like kind of like unwinding and just making good food for fall. So I'm really excited for that. So. Oh, Howard, I do a little bit of both, but I'm spoiled. My son is an amazing cook. Oh, that's awesome. Does your son have a preference? Like, does he specialize on anything in particular, a particular kind of cuisine, like Canadian cuisine or like Mexican cuisine, or like does he have like a preference on like what he does? For me, I kind of just, I guess like you could say like for me personally, like I for cooking I'm very generic, but like for baking, I definitely have got like a North American flair as far as like I make like fancy chocolate chip cookies, but not like normal ones. Like there's a specific kind that originates from New York that I really like making, and Nanaimo bars, which is a recipe I picked up from Canada. By the way, the Canadians are incredible for making that thing. Nanaimo bars are incredible. Thank you for this contribution to the world. Like, man, those are so good. So, and then just like other things here and there. But, oh, Quackers, I think it's the difference between being intuitive flavors, cooking, and being intuitive the science, how the ingredients work, baking. That totally makes sense, because I'm very analytical and very like, I like having the precise measurements and stuff, so that lends itself to baking really well. So, same for me and my friends. So anytime I want something, I just ask them. Love it, love it. Oh, cool, Howard. He cooks fish and steak to a T. That is so cool. Oh my gosh, man, that's awesome. Well, yeah, that's really really cool that he does that. Especially like, I feel like fish, depending on the species, it can be pretty hard to prepare. So, dude, kudos to your son. That is so so cool. Oh my gosh. So, Quackers, today we had our first chill. So excited. Yes, it's that time of year. Um, I'm analytical. I tend to ignore the recipe because who needs them anyways? Yeah. Yeah, I do that. Like, I have mixed results when I do that. Sometimes they're hits and sometimes they're like misses. So, but yeah, like, but I'm excited. I am trying to do one more dive. I'm going to be going to North Carolina in October, but on the Crystal Coast, to where the Gulf Stream is still hitting the coastline, so the water should still be warm. The diving there is usually for advanced people. There are some sites that I think are accessible for kind of like newer divers. So I'm trying to hit one of those up, and that will be the last one of the year. But in the meantime, in Virginia, it's going to still continue to get colder. So it's like I'm here for the fall. I'm holding on to this one little threshold of summer in the form of, hopefully, fingers crossed, we can pull this trip off. But you know, we'll see. That's going to be up in the air. But fingers crossed. So I'm kind of in this mixed zone of like, I want to hold on to the summer, but I really love the fall comfort and, like, movies and food, and just I am excited for this time of year. So, but it's 11. Probably wrap up in a bit, but I'm super excited for. Oh man, let me star this. Like, Howard, I love this comment. If your kids take an interest in something productive, encourage them. Yes, I'm starring that because that like I 100% support that, and that's really cool because that allows something to flower that's really special in terms of like just it's something special to them, but it's also something that like benefits everybody. In this case, it's delicious food, so that's really really cool. But thank you guys so much for watching. This was a really fun stream with the Knifetooth Dogfish. I like that this was kind of a rare species and like little is known about it, but we did get really really cool information, especially about just the evolution of bioluminescence in this group of sharks, and also like how it like I guess I didn't realize that the sleeper sharks devolved bioluminescence. It's like it was part of a group that evolved it and then it devolved it later. So, which is really cool to see. And it is really cool to see the Knifetooth Dogfish's unique dentition, from which it gets its name, and how the research is starting to kind of. It shows that we suspect it handles larger prey, but it might be actually eating smaller prey. So it's kind of cool to see how the research evolved. But tune in next week for the Dusky Shark. I am super, super excited for the Dusky Sharks. This is like the best kept secret as far as sharks go. They're not a very well-known species, and I think part of it is like they're kind of hard to identify. They look pretty. There's a lot of subtleties to their form, but they're pretty cool as far as just like big, big sharks, big, powerful sharks that really need our help. So tune in for Dusky Shark. I'm super excited next week. Oh, thanks, guys. Thank you guys so much for watching. Really love the comments. Oh, man. Thank you, guys. You guys make my week as well, and I love spending this time with you. But hope you guys have a great week, and we'll see you again for the Dusky Shark next week. But cheers, guys. Take care.